On the 23rd of September, 1846, a young astronomer in Berlin named Johann Gottfried Galle pointed his telescope at a precise patch of sky and found something that should not have been visible. A blue-green disk, faint and steady, exactly where the mathematics said it would be. He had just discovered Neptune. That was 1 Neptune year ago. Not 1 human year, not a century, 1 Neptune year. Neptune takes 165 Earth years to complete a single orbit around the Sun. We discovered it in 1846. It completed its first full orbit since discovery in 2011. Think about what happened on Earth in that single Neptune year. The American Civil War, the invention of the telephone, 2 world wars, the rise and fall of entire empires, the first airplane, the first satellite, the first human footprint on the moon, the fall of the Berlin Wall, the internet, the mapping of the human genome. All of that, every single one of those events, happened in less than 1 Neptune year. 1 orbit. 1. And it is not finished. Neptune's second orbit since discovery will not be complete until the year 2176. No human alive today will see it. But before we talk about what 1 Neptune year actually means, we need to talk about how Neptune was found, because the story of its discovery is one of the most extraordinary moments in the history of science. In the early 1800s, astronomers carefully tracking the orbit of Uranus noticed something was wrong. The planet was not moving where it should be. Not dramatically, not obviously, just slightly off by fractions of a degree, accumulated over decades of careful observation. But the deviation was real, consistent, and growing. Something was pulling at Uranus. Some unseen gravitational influence was tugging at its orbit from somewhere further out in the dark. 2 mathematicians, Urbain Le Verrier in France and John Couch Adams in England, working independently and without knowledge of each other, both decided to solve for it. They took the deviations in Uranus's orbit and worked backward through the mathematics of gravity to calculate where the unknown object had to be. Their calculations took months. The math was brutal. No computers, no calculators, just hand calculation of orbital mechanics across millions of kilometers of space. And when they finished, both of them pointed at the same spot. On the 23rd of September, 1846, Le Verrier's prediction was handed to Galle at the Berlin Observatory. That same night, Galle turned his telescope to the precise coordinates and found Neptune within 35 minutes of searching. It was within 1 degree of where Le Verrier had predicted it would be. This was not luck. This was one of the purest demonstrations of the power of mathematics ever performed. Before a single photon of Neptune's light had passed through a human lens, before anyone had seen it, Neptune was already known. The universe had been solved for it. But here is the detail that matters for our story. From the moment humans first saw Neptune, it began a new cycle of its orbit. The clock started, and it has only just finished that first lap. Let us stay with this for a moment. Really stay with it. Because 165 years sounds like a long time, but it is not a geological span. It is not an evolutionary span. It is a human span, the kind of time that fits inside the arc of recorded history, inside the memory of institutions, inside the distance between a great-great-grandparent and a grandchild. When Neptune was discovered in 1846, Abraham Lincoln was a 37-year-old lawyer in Illinois who had never held national office. The United States had 29 states. Photography was 6 years old. The first anesthetic had not yet been used in surgery. Queen Victoria had been on the British throne for 9 years. The British Empire covered approximately 1/4 of the Earth's land surface. The Qing dynasty ruled China. The Ottoman Empire stretched across 3 continents. There were no cars, no telephones, no electric lights, no recorded music, no antibiotics, no aircraft, no radio, no nuclear weapons, no plastics, no internet. All of that came and went in 1 Neptune year. By the time Neptune completed its first orbit in 2011, the year, astronomers confirmed It had returned to its discovery position. The world that discovered it was unrecognizable. The Berlin observatory where Galle made his discovery is still there. The mathematics Verrier used to find Neptune, refined and extended now, guides spacecraft across the entire solar system. But otherwise, essentially nothing about the civilization that found Neptune still exists in its original form, and Neptune noticed none of it. It was simply moving, the way it has been moving for 4.5 billion years, the way it will move for billions more. 165 years is a civilization to us. To Neptune, it is Tuesday. Now let's make this visceral, because the mathematics of Neptune's orbit have physical consequences, and those consequences are extreme. Neptune orbits at an average distance of approximately 4.5 billion kilometers from the Sun. At that distance, the Sun delivers roughly 900 times less energy per square meter than it delivers to Earth. 900 times less. The Sun, from Neptune's surface, is not the warm yellow disk that governs our seasons and our moods and our agriculture. It is a very bright star, the brightest star in Neptune's sky by far, but a star, not a presence, not a warmth. Just a source of faint, distant light that illuminates without heating, that defines day and night without making either one comfortable. The temperature at Neptune's cloud tops sits at around -214 degrees Celsius. Nothing melts, nothing evaporates. Nothing circulates the way weather circulates on Earth, driven by uneven solar heating, by the rhythm of seasons, by the difference between a warm equator and cold poles. And yet Neptune has the most violent weather in the solar system. Its seasons are unlike anything we can intuitively understand. Because Neptune's axial tilt is 28 degrees, similar to Earth's 23, it does have seasons. But each season lasts approximately 41 Earth years. 41 years. Spring on Neptune. Summer on Neptune. Autumn on Neptune. Winter on Neptune. Each one 4 decades long. A child born at the beginning of a Neptune summer would be in their 40s before autumn arrived. They would be in their 80s before the next summer began. Every human being who has ever lived has existed within, at most, 2 Neptune seasons. Most of us will experience one. Let's talk about the physics of why Neptune's year is so long, because it is not simply that Neptune is far away. It is that distance and orbital velocity interact in a specific, counterintuitive way. Kepler's third law of planetary motion states that the square of a planet's orbital period is proportional to the cube of its average distance from the Sun. In plain language, the further a planet is from the Sun, the slower it moves, and the longer its year is. But the relationship is not linear. It is cubed. Mercury, the innermost planet, orbits at approximately 47 kilometers per second and completes a year in 88 Earth days. Earth orbits at approximately 29.8 kilometers per second. Neptune orbits at approximately 5.4 kilometers per second. 5.4. That is slower than many spacecraft we have launched from Earth using chemical rockets. The New Horizons probe, launched in 2006, left Earth's gravitational influence at approximately 16 kilometers per second, nearly 3 times Neptune's orbital speed. At 5.4 kilometers per second, Neptune is moving through space at roughly the speed of a hypersonic aircraft, fast by any human standard. But the distance, it must cover the full circumference of an orbit roughly 28 billion kilometers in total length, means each circuit takes 165 Earth years. And it does this continuously, without pause, without acceleration, without any assistance. Neptune has completed approximately 27 million orbits since the solar system formed. Each one identical, each one taking 165 years, each one witnessed by no one. Let us go back to that single orbit, the one we watched. 1846 to 2011. 165 years. 1 Neptune year. In 1846, the fastest form of long-distance communication was a letter carried by horse. By 2011, A message could travel from London to Tokyo in approximately 50 milliseconds, carried by light pulses through fiber optic cables laid across the ocean floor. In 1846, the human population of Earth was approximately 1.2 billion people. By 2011, it was approximately 7 billion. In 1846, the average life expectancy in Europe was approximately 40 years. By 2011, it was approximately 80. In 1846, humans had never left the surface of the Earth under their own power. By 2011, humans had walked on the moon, launched probes to every planet in the solar system, placed a telescope in orbit that could see 13 billion light-years in every direction, and sent 2 spacecraft, Voyager 1 and Voyager 2, beyond the boundary of the solar system itself. We went from horse-drawn carriages to interstellar space in 1 Neptune year. The probe that first photographed Neptune up close, Voyager 2, was launched in 1977, flew past Neptune in 1989, and is now traveling through interstellar space beyond the heliopause. The entire Voyager mission from launch to interstellar space took place in less than 1 Neptune year. Everything we have ever done with spacecraft, every mission, every planet we have visited, every photograph taken from beyond Earth's atmosphere, everything happened in 1 Neptune year. And Neptune's second orbit, the one that started in 2011, has already begun. It will end in 2176. The second Neptune year since discovery will run from 2011 to 2176. We are inside it right now. And what we do in this orbit matters because we have sent exactly 1 spacecraft to Neptune. 1. Voyager 2 flew past in August of 1989, 35 years ago. It had approximately 6 hours at close range. Everything we know about Neptune's rings, about Triton's geysers, about the Great Dark Spot, all of it came from those 6 hours. Since then, nothing. No orbiter, no atmospheric probe, no lander on Triton, no mission of any kind. The Planetary Science Decadal Survey, the document that tells NASA which missions to prioritize, has repeatedly included a Neptune orbiter as a high-priority target. In 2023, a mission concept called Trident was proposed, a flyby spacecraft specifically designed to study Triton's potential subsurface ocean and Neptune's unusual magnetic field. It has not been funded. If a mission were approved and launched in the early 2030s, it could reach Neptune in the 2040s. That would be 55 years after Voyager 2's flyby, more than half of 1 Neptune season after our last visit. We are currently planning, tentatively, unfunded, aspirationally, to return to a planet we visited for 6 hours, 35 years ago, and have not approached since. In the second Neptune year since discovery, we have an opportunity. The question is whether we will take it. Step back. Think about what it means that Neptune has not finished a single orbit since we discovered it. It means that every human institution that has ever existed, every government, every religion, every university, every corporation, every army, has existed within 1 Neptune year. The United States of America is younger than 1 Neptune year. The entire modern scientific tradition, from Galileo to the James Webb Space Telescope, fits inside 1 Neptune year. The Roman Empire, at its height, lasted approximately 500 years. 3 Neptune years. Ancient Egypt, one of the longest-lasting civilizations in human history, lasted approximately 3,000 years, 18 Neptune years. The entire span of recorded human history from the first Sumerian writing to this moment is approximately 5,000 years, 30 Neptune years. Neptune has been orbiting the Sun for approximately 4.5 billion years. That is approximately 27 million Neptune years. We have witnessed one of them, 1. And in that 1 orbit, we went from horse-drawn carriages to interstellar spacecraft. We doubled the human lifespan. We mapped the human genome. We split the atom. We connected every human on Earth into a single information network. One orbit. Imagine what 27 million looks like. Imagine what Neptune has seen, or rather, what it has not seen, because it sees nothing, notices nothing, cares about nothing. It moves in complete indifference. It does not know we exist. It does not know we found it. It does not know we sent a machine to photograph it for 6 hours and then left and never came back. It just moves. 5.4 kilometers per second. 165 years per lap. Around and around, in the dark, 3 billion miles from a sun that is barely a star from this distance. Right now, at this moment, Neptune is somewhere in its second orbit since discovery. It is approximately 1/5 of the way through. The next time it completes a lap, it will be the year 2176. The people who will witness that moment have not yet been born. What will they know about Neptune that we do not? What will they have sent there? What will they have found? We do not know. All we know is that Neptune will still be moving 5.4 kilometers per second, around and around, waiting, in its indifferent way, for someone to come back and look.